Hello students, welcome to Sure of Sir's classes. You can reach us at www.sureofsirclasses.com or call us or WhatsApp us in case of any queries or clarifications at 9836793076. You can also email us at sureofsirclasses@gmail.com. So today we'll be solving some IIT JAM Chemistry questions from this year, that is 2018. Let's move on. We have question number 52 in hand. Sodium decays to 1/4 of its initial amount in 29.8 hours. Its decay constant is, and we have to find the decay constant in a unit of hour to the power -1, so inverse of hour, and rounded up to 4 decimal places. So we have to find the decay constant of a sodium decaying. So basically we all know that for decay reactions, each and every of them follow the first order kinetics. So the rate constant or the decay constant will be equals to 2.303, because we will be taking in log in base 10 by T, and here the concentration initially, so this is the initial concentration divided by the final concentration, that is the concentration at time t. Concentration of A left at time equals to T. So in this question there is basically nothing, you have to put the values here. So this is 29.8, time is given as 29.8, so this will be in hour inverse, and 2.303 above log base 10. A naught is not given, but AT is given as 1/4 of its initial concentration. So concentration of A left at time equals to T will be 1/4 of A naught. So this is the concentration left at time equals to 29.8 hours. So this will basically be replaced by 1/4 A naught, and subsequently these A naughts will cancel, and we will get 2.303 by 29.8 log base 10 into 4, that is log 4 base 10. This will be equal to 0.0465 hour inverse, and this is the decay constant. So the answer will be 0.0465, since we have rounded it to 4 decimal places. So the answer is 0.0465. Next we have question number 53. The magnitude of crystal stabilization energy, or CFSE, of octahedral TiH2O6 3+ complex is 7680 cm inverse. So CFSE of TiH2O6 has been given as 7680 cm inverse. The wavelength at the maximum absorption, or Lambda Max, of this complex is, and we have to find out the value of the wavelength at the maximum absorption, or Lambda Max. So this is rounded up to the nearest integer and is given in nanometers. So we have to do the adequate conversions, the necessary conversions. So starting with the question, we have TiH2O6 3+. So the electronic configuration of this complex is argon 18 3d1. Therefore CFSE we know is equals to -0.4 into the number of electrons. X here represents the number of electrons occupying T2G orbital, and plus 0.6 into Y del naught. Okay, I'm writing it here again. CFSE equals to minus 0.4x plus 0.6 y into del naught, where x represents the number of electrons occupying T2G orbital and y represents the number of electrons occupying the EG orbitals. So in this case, since the electronic configuration of TiH2O6 3 plus has 3d1, so this is in T2G orbital because it is a octahedral complex, and the T2G will be filled before EG, and since there is only one electron to fill, so the T2G will be the one filled. So we have been given that the CFSE is 7680 centimeter inverse. So CFSE from the formula of this formula is equals to negative of 0.4 and x is only 1, whereas the value of y is 0, so this is basically the whole expression. So the CFSE will be minus 0.4 del naught, and it has been given as 7680, so the value of del naught will be equal to 7680 by 0.4, which is equals to 19200 centimeter inverse. Now we have to find the lambda max. So 1 by lambda max will be equals to 19200 centimeter inverse. Hence lambda max will be equal to 1 by 19200 in centimeters. So this will be equal to, so lambda max will be equal to 520.83 into, we are converting the expression from centimeter to meter, and subsequently 10 to the minus 9 is nanometers. So this will be equal to 520.83 nanometers, and since we have been asked to round up to the nearest integers, so this will be 521. So lambda max will be 521 nanometers. So the answer will be 521. Hence the answer is 521. Thank you.